Now I'm going to start with the x-axis symmetry. So to test for x-axis symmetry, we're just going to plug this, right? So plug x negative y into the function, and then check if we're getting the function back, right? So this is our y value. Okay, so let's plug it. So x is going to be plugged in x, negative y is going to be plugged in negative y. So then we'll have negative y equal to 4 times cube root of x, which you can multiply both sides by negative 1. This will be negative times that, right? Therefore, we can have this. So let's write it like this. So negative. So this guy right here, see this right here is going to be the original y, but so you don't get the original one back, right? You get the opposite of that back. So because this negative right here is sort of extra. So there is not going to be x-axis symmetry here, right? So let's check for y-axis symmetry. Symmetry, y-axis symmetry. So for y-axis symmetry, now we're gonna plug negative xy. When we do that, then y is gonna be 4 times negative x right here. But this will be the same as 4 times cube root of negative 1 times x, but cube root of negative 1 will be, so you can write it like this, cube root of negative 1 times cube root of x, but this guy is negative 1. So again, this will just turn into y equal to negative 4 times cube root of x, and that's not the same as the original. So there is no x-axis symmetry. So no x-axis symmetry and no y-axis symmetry. Now let's check the last one. The last one is origin symmetry. And origin symmetry is this. So for origin symmetry, we have to plug negative x, negative y. We change both, sign of both. So therefore, negative y equal 4 times cube root of negative x. Negative y equal 4 times. And actually, we just simplified this in the previous part, which is like negative 1 times positive x, negative y equal to 4 times cube root of negative 1 times cube root of x. But this guy is negative 1, so therefore we'll have negative y equal negative 4 times cube root of x, which you can multiply both sides by negative 1, and you will go back to the original one. Exactly the original one, right? So that means yes, we do have a symmetry. So we only have origin symmetry for this function. If you use your calculator, you can actually see that this function, graph of this function is sort of like this, and that's exactly symmetric with respect to origin. So no x-axis symmetry, no y-axis symmetry. Origin symmetry, yes, we do have origin symmetry for this function.